can I say, I had time to have a coffee. I hope you also had the time to at least take a small break and have a coffee, because like I said, we have a long day in front of us, but full of content, and I can promise to you interesting content. So let's get back to the second part of the day, which will contain a brief overview of the call and of the topics. We mentioned in the morning, several of the speakers mentioned the number, 41 topics. So we will now have the challenge to walk you through 41 topics. Of course, we will not read the hundreds of pages, but I have here with me a part of my team, the project officers that are always supporting me, not only with the preparation of such call, but then with the entire implementation, evaluations, and follow-up of all the projects. So let me start with the first one, Nikos Limperopoulos, project officer in charge of hydrogen production, and he will talk about, of course, the renewable hydrogen production on behalf of also of his colleagues Dionysis Tsimis and Claudiu Pavel, who are sharing with him the portfolio of renewable hydrogen production. Nikos, the floor is yours, if you could hear me and could take up from me.
Yes, thank you, Mirella. I can hear you. I hope you can also hear me. Good morning, everyone. I will very quickly breeze through the 10 topics that fall under the renewable hydrogen production area. Next slide, please. So the main focus is, like in previous framework programs, the cost reduction and efficiency increase for renewable hydrogen production pathways, which is mostly electrolyzers, but also alternative routes to electrolysis. Here you can see the current focus, which is on increasing the operating pressure of low and high temperature electrolyzers, increasing the cells and stacks of electrolyzers in size. Then we have some large-scale electrolyzer demonstrations in industry, in off-grid locations, and in offshore locations. There is also a topic on improved efficiency of solar thermochemical hydrogen production using concentrated solar. What is new compared to past frameworks is the emphasis on circularity and recyclability of materials and components of electrolyzers, and also specific support to electrolyzer manufacturing. Next slide, please. So the two next slides summarize in this table format the 10 topics. Here we can see topics 1.1 up to 1.6. These are all research and innovation actions, so mostly research focusing projects. You can see the budget ranging from 2 all the way up to 6 million euro of clean hydrogen JU support. For some of the topics, it's a 2 times, meaning that we can support more than one project, provided the second one is complementary to the first one. And you can also see the deadlines for submission of proposals being either end of May or 20th of September. Next slide, please. Topics 1.7 to 1.10 have 1 research and innovation action and 3 innovation actions or large demonstration projects with more major budgets of 9, 18 or 20 million euro. 2 are flagship projects that, as already mentioned, have a deadline 20th of September. Next slide, please. And let's start looking at the topics now very briefly, and the advice is always for proposers to look at the details of a description of each topic. So these 2 topics are quite similar. It's increasing the operating pressure of high temperature electrolyzers. Topic 1.1 is for solid oxide electrolyzers, game changer solid oxide electrolyzers, aiming for operation at more than 5 bar, something rather challenging to these high temperature electrolyzers usually operating at atmospheric pressures, to be demonstrated at a capacity of more than 10 kilowatts, tested more than 2,000 hours at a high current density of 0.85 amps per centimeter squared, keeping an eye on degradation. You can see the targets on CapEx and on the efficiency. There is also the circularity by design for materials. Now, I should mention here that for all our topics on electrolysis research, the consortium should eventually test the electrolyzer according to the testing protocols developed by the Joint Research Center. This applies to all electrolyzer topics. Topic 1.2 is almost identical to 1.1, with the exception is focusing on proton conducting ceramic electrolysis. Again, more than 5 bar operation, but now a 5 kilowatt stack with a lower current density. So you will see that the text is almost identical, but we're also ring fencing the budget, ensuring both types of electrolyzers receive support. Next slide, please. Now, topic 1.3, it's again the same, but for like high temperature operation, but for low temperature electrolyzers. But this time the pressure is high enough to allow for gas grid injection, avoiding mechanical compressors for improved efficiency and reliability of systems. So the aim is to go for more than 50 bar for alkaline and anion exchange membrane electrolyzers, and more than 80 bar for PEM electrolyzers. Temperatures are also expected to be higher. Now, systems to be developed with more than 50 kilowatt for alkaline and PEM, and more than 25 kilowatt for anion exchange membrane, which is quite challenging. We can support 2 projects, but the 3 different types of electrolyzers will be competing between them. So eventually we could be supporting 2 alkaline electrolyzer projects if they have the highest ranking. Efficiency increase of 2 to 4% low heating value of hydrogen is aimed for, to be gained by avoiding a mechanical compressor. And this is to be achieved through breakthroughs in stack design, materials, and cell components. Topic 1.4 is focusing on manufacturing of electrolyzers, where novel components and processes will eventually be integrated in developing a demonstrator stack. To be developed are new surface coating technologies, advanced manufacturing processes like 3D printing, things that we have already seen being implemented in fuel cell manufacturing. Also targeting improvement of manufacturing throughputs and level of automation to produce the stack, aiming for reduced manufacturing times and costs. Consortia should pay attention to include at least 1 electrolyzer original equipment manufacturer, 1 actor from the manufacturing sector, and at least 1 SME. Also, please try and explore synergies with the Made in Europe partnership under Cluster 7. Next slide, please. Topic 1.5 is aiming to scale up cells and stacks for large electrolyzers. So to design, construct cells, eventually leading to a single 10 megawatt stack. Is this viable? This is going to be the topic to be answered, the question to be answered. So the aim is to scale up cell active areas by at least 2 times, go for higher current densities, appropriately scale up the balance of plant, ensure compact design, minimize weight and footprint. We are not going to be supporting the building of a single 10 megawatt stack, but instead several short stacks in order to identify the optimal sizes for larger cell stacks from a scientific, engineering, logistics, economic point of view. At the end of the day, is it best to go for single 10 megawatt or for smaller multiple stacks to 10 megawatt modules? That should be the answer for this topic. Topic 1.6 is the alternative to electrolysis, renewable hydrogen production route. It's the concentrated solar for solar thermochemical water splitting, aiming to prove that this is a viable alternative to electrolysis route for producing renewable hydrogen. A very ambitious solar to hydrogen efficiency of more than 10% through process intensification, better exploitation of the and recuperation of the heat generated, aiming for an efficiency of 0.75 kilograms per year per square meter of land area used for solar concentration factors of 1,000 times. At a megawatt scale, the target is to produce hydrogen at less than €5 per kilogram, and the projects should demonstrate an on-sun facility between 50 to 300 kilowatt operating for a minimum of 6 months. Here, we advise you to seek collaboration with the European Innovation Council Pathfinder Challenge projects. Next slide, please. Topic 1.7, this is an innovation action, is aiming to bring renewable hydrogen at megawatt scale off-grid installations closer to technical and financial maturity. So we aim to demonstrate the complete value chain of off-grid hydrogen production, including storage and end use at megawatt scale at 3 to 5 megawatt to be precise, covering the renewables and hydrogen production capacities. Now, this topic has the potential to include changes in the renewables technologies, not only in the power electronics, in the DC to DC bus, but also to the renewable. And the question is, could maybe one day we see a wind turbine producing hydrogen molecules rather than electrons? The electrolyzer will have to be obviously highly flexible with a suitable balance of plant, and probably electricity storage will need to be incorporated in the system. And like I mentioned previously, costs along the whole value chain are eligible. Topic 1.8 is our large electrolyzer multi-megawatt demonstration in industrial environment. This is a continuation of our past large electrolyzer demonstration projects. This is complementary to the Green Deal 100 megawatt projects. We always support novel electrolyzers, electrolyzers that are beyond the state of the art, that will be demonstrated in a specific industrial application. We expect that it will be a bigger than 25 megawatt electrolyzer, could be low temperature or high temperature. Possible innovations could be to supply possibly more than one customers, to possibly make use not only of the hydrogen, but also the oxygen and heat that's being generated or ejected, to provide electricity balancing grid services to reduce footprint. The proposal should foresee a go, no-go decision following the initial stages of the project and the FID, etc. And eventually, after the facility is built, to foresee a 2-year operation of the electrolyzer. Here, we encourage you to seek synergies with the P4P, or Process for Planet partnership, or the Clean Steel Partnership, which support the development of downstream for us facilities that operate on renewable hydrogen. So we will be supporting the electrolyzer, but the downstream industrial process we cannot support. Support should be sought from alternative sources. Next and final slide, topic 1.9, is aiming to scale up solid oxide electrolyzer technologies, scaling up cells and stacks, eventually modules. The aimed stack capacity is 250 kilowatts, the module capacity, but in the context of this topic, only an 80 kilowatt module is to be built, incorporating larger than normal stacks. At megawatt level, the footprint target would be less than 150 square meters per megawatt, a current density of 0.85 amps per square centimeter. And the module should be tested for more than 2,000 hours. Also, the production method should be demonstrated during this project. The last topic this year is topic 1.10, is the demonstration of offshore production of renewable hydrogen with 20 million of clean hydrogen JU support a flagship project like topic 1.8. So we expect that at least a 5 megawatt electrolyzer will be integrated in an offshore infrastructure. The aim was to keep this topic as broad as possible, either integrated into an existing offshore oil and gas infrastructure where, besides the cost of the electrolyzer, there would be high cost on bringing renewable electricity from offshore wind to that platform, and then possibly export the hydrogen using an existing pipeline to the shore, or integrate the electrolyzer on a wind turbine or close to a offshore wind park, so readily available electricity, but then a high cost to transport the hydrogen to the shore through a pipeline. By implementing such a project, all the challenges in terms of safety aspects, remote control, autonomous operation, inspection, maintenance should be addressed. The project would involve the design, construction in 2 years of operation of the facility to assess performance in terms of degradation in such a salty environment, to assess operational and maintenance costs, and eventually try and understand the economic viability of either trying to exploit existing offshore infrastructures or focusing in building new ones. And with this, I would like to thank you for your attention. Happy to answer any questions, and it's back to you, Mirella.
Thank you very much, Nikos. Thank you very much for guiding us and walking us through the first 10 topics of the call. I think for all the speakers, for all the applicants, for the attendance, you could see already the focus of our first 10 topics, mainly on electrolysis, but also on other routes. And as you can see, we are also trying to demonstrate, to get into the field and even demonstrate this technology, the electrolysis technology in different environments, in the industrial environment, or coupled with offshore renewable sources. Nikos, if you could stay with us in case we have questions to the end. Now, I would like to move on and to give the floor to our next project officer, Dionysis Tsimis. He is going to present us and guide us through the topics related to distribution, storage of hydrogen. Dionysis, the floor is yours.
And good morning to everyone from my side as well. I'll be briefly going over the topics on the area of hydrogen storage and distribution that I cover together with my colleagues Lionel Boyot and Pietro Caloprisco, who will be also joining us in the FAQ session to take any questions you might have. Looking at the overview and what is the main focus in this application area, the main focus this year will be on improved hydrogen carriers, on preparing hydrogen refueling stations for the demands of heavy-duty applications, and on scaling up innovative hydrogen compression solutions. And we also have some new elements in this year's topics. We're focusing on next-generation liquefaction units and large-scale liquid hydrogen storage for the bulk shipping of hydrogen. Among other things that are new, we also have the development of increased capacity tube trailers, and also on improving the quality control for the hydrogen dispensed in the hydrogen refueling stations, ensuring that there is intercomparison between the laboratories in Europe, that they're all able to detect impurities. Looking at the overview of the topics, here, this is mainly for future reference, for you to have a look. This is the first 6 of the topics in this area. As you can see, they're all research and innovation actions. You can see the indicative budget that is foreseen for these topics, And also on the far right, you can see the two different deadlines that we have for the topics. With green, it's the 20th of September, and in blue, it's the end of May. I will not go into detail on each of the topics, as we will follow up on that in the next slides. And these are the rest of the topics in this hydrogen storage and distribution area. Here, just to point out that we have in topic 2.10, we are foreseeing that we will have two topics funded under this, two proposals funded under this topic, each with 4 million euros. So, moving on to the topic descriptions. We start with topic 2.1, which is looking at the compatibility of the distribution grid with hydrogen, and specifically looking at the non-steel metallic materials. The main aim of the topic is to test and improve the compatibility of the natural gas distribution network with hydrogen mixtures. One of the aims is to deliver a preliminary inventory of the non-steel metallic materials in the distribution grid and test the effect of hydrogen on these materials in concentrations, in mixtures up to 20% with natural gas, and then going up to 100% hydrogen. It is foreseen for the topic to create a database of results that is publicly accessible for the results of the testing, indicating the behavior of the non-steel metallic materials in the presence of hydrogen. Then we move on to topic 2.2. 2.2 is focusing on the development and validation of reliable sensor technologies for both detecting leakages of hydrogen, but also leakages of mixtures of hydrogen with natural gas. The proposal should develop new and optimized leak detection sensors in order to enable the safer storage, transportation, and distribution of hydrogen. It is foreseen that the proposed technology should be suitable for continuous leak detection monitoring and/or periodic maintenance. And the scope of the topic is open to any kind of sensing technology. We can move on to the third topic, topic 2.3, where we're looking at the validation of a high-performance hydrogen liquefier prototype. The main aim of the topic is to develop and validate an improved hydrogen liquefaction system. It is foreseen that the proposer should focus on an innovative concept at either system level or on one of the subsystems that are described in the topic description. Then to proceed to a construction of an industrial prototype at limited scale, and to evaluate the performance, durability, and efficiency of the prototype. Next, we have topic 2.4, where we're looking at one of the hydrogen carriers being ammonia, and looking specifically at the dehydrogenation aspect of it. The applicants are expected to develop and test an improved ammonia dehydrogenation system. The work should focus around the catalyst and the reactor of the dehydrogenation unit, and it is expected to develop a system that will be demonstrated for at least 500 hours, producing at least 10 kilograms of hydrogen per day. It is also expected that there will be a design foreseen for the scalability of this system to be demonstrated to up to 100 tons of hydrogen per day. And moving on to topic 2.5, which is a very similar topic to the previous one I just described on ammonia, but this time dealing with liquid organic hydrogen carriers. Here the main aim is to develop and test an improved liquid organic hydrogen carrier dehydrogenation system. Again, the work should focus on the catalyst and the reactor of the unit. The system needs to be demonstrated for at least 500 hours in the same principle as before, and producing at least 10 kilograms of hydrogen per day. And similarly to the previous topic, the scalability should be demonstrated up to 100 tons of hydrogen per day. Next, we have topic 2.6, which is looking at the development of large-scale liquid hydrogen containment for shipping. Here we're looking to develop and validate containment concepts intended for the bulk shipping of liquid hydrogen. It is foreseen that the proposal should go through a concept selection for large-scale liquid hydrogen containment to be used in shipping. It is foreseen to focus on the detailed design, construction, and testing of a scaled-down prototype of at least 10 tons of liquid H2. And it is important to seek the general approval for the containment system by one of the major IACS classification societies. Next up, we have topic 2.7, which is looking at the increased hydrogen capacity of gaseous road trailers. Here we're looking at developing and validating a solution with a minimum payload of 1.2 ton of compressed hydrogen above 500 bar. The applicant should propose new solutions to decrease the specific weight of the package. And examples of solutions could be lighter tubes, larger diameter composite tubes, etc. But it's not limited to these options. The applicants should also identify if the proposed solutions are covered by existing standards and the regulations, or if adaptations are necessary. Moving on to topic 2.8. Here we're looking at the development of novel or hybrid concepts for reliable, high capacity and energy efficient H2 compression systems at real world scale. It is important to develop, scale up, build and install and test a compression prototype at a client site with real life application. The solution is expected to demonstrate high levels of availability and efficiency with low costs, low maintenance requirements, and high operational safety. The demonstration should be at least for 1 year of real commercial use and should have a projected lifetime of at least 20 years. Next up, we're moving into hydrogen refueling stations. And topic 2.9 focuses on sampling methodology and quality assessment of hydrogen refueling stations. And the overall aim of this topic is to ensure that the hydrogen quality that is dispensed can be accurately measured according to the relevant standards. One of the main actions foreseen in the topic is to validate the capability of at least 5 EU-based hydrogen purity laboratories for both sampling as well as analyzing hydrogen according to the applicable standards. And one of the expected outputs is a publicly accessible hydrogen quality database representing the hydrogen quality supplied in the EU. Staying in the topic of the hydrogen refueling stations, we move on to topic 2.10, where we're looking at implementing new or optimized refueling protocols and components for high-flow hydrogen refueling stations that are necessary for heavy-duty applications. And here we're looking at validating the new fueling protocols that are being developed for heavy-duty applications, as well as all the necessary components that will allow high-capacity refueling. It is expected that proposals will address the qualifications of the components necessary to achieve the specific flow rates, but also the qualification of the protocol by testing it in full assembly with all the developed components. In terms of the timeline foreseen for the project, it is expected that at least 2.5 years are foreseen for the development of the components, and allowing 1.5 years for the integration and testing of the components in a full refueling line assembly. Moving on to the last topic of this area, topic 2.11. Here we're looking at the development and demonstration of mobile and stationary compressed hydrogen refueling stations for inland shipping and short-distance maritime operations. It is expected that the applicants will focus either in a stationary pipe-to-ship or on a floating ship-to-ship or a platform-to-ship solution. And it is expected that they will demonstrate a smart and safe logistics solution and develop a market standard to support front-running shipping projects. One of the main outcomes as well is a techno-economic analysis of the proposed solution, as well as the standardization of the developed engineering solutions, including all the relevant components. It is expected that synergies will be foreseen by the applicants with topic 3.5, that is planning to deploy 5 inland vessels. That brings me to the end of my presentation. I would like to thank you very much for your attention, and I will be happy to answer any questions in the FAQ session. Mirella, the word is back to you. Thank you very much.
Thank you very much, Dionysis. And again, for all of you, I thank you for you've seen again Dionysis walking us through the other 11 topics. So we're getting there. We're getting to the middle of the call. Thank you again very much for this presentation. And we are moving on now into the end uses. And we will start with Pietro Caloprisco, project officer, one of the project officers in charge of this portfolio of projects. And he will guide us through the transport application topics. Without taking more time, I hope the presentation is coming. Pietro, the floor is yours.
Perfect. Thank you very much, Mirella, and good morning, everybody. Indeed, with my presentation, I will walk you through the 8 topics that in this call are dedicated to the transport applications. So let us start, first of all, by seeing what is the overall focus and what are some of the key novelties that we would like to highlight. Well, first of all, as you will see, compared to the past, there is a very strong focus toward the adaptation of the single fuel cell, of the components of the fuel cell system toward the heavy-duty applications, be that on road, maritime, or aviation. Speaking about aviation, there is also an overall quite strong focus on this transport mode. There is a strong push toward the propulsion, and this is done through the upscaling of the stack, as well as through the development of liquid hydrogen storage solutions. And in general, if we are looking at how we are transitioning from the old joint undertaking to the new one, you will see that there is also a continuous, because we are trying to bring to fruition the results of the demonstration projects that we had in the past, especially when it comes to heavy-duty road applications and inland waterways. And that leads me also to our next point, which is what are the novelties. Well, it was mentioned earlier this morning that we have two large flagship projects within the transport, especially. One is dedicated to road application, so a deployment of 150 trucks, and the other one is focused on the inland waterways with a deployment of a fleet of 5 vessels. And beside the technical aspects, we have also highlighted clearly how it will be important this time around to have also strong cooperation with other programs, such as the Clean Europe Facility for Transport program, for financing on one side of the infrastructure through their programs, through their calls, and the vehicles through our call. If we look at the overview, as here you can see, these are the 8 topics. 6 of them are research and innovation actions, while the other 2 are these large innovation actions, the 2 flagship projects, with the exception of the first one that has a deadline in September. All the proposals for the other calls will have to be submitted by the end of May of this year. Let us now go through these 8 topics to see what are the key features of each one of them. So we start with the road transport, where we have 4 calls. We start especially with the building blocks, so the development of the stack, in this case for heavy-duty applications. As I mentioned at the beginning, there is a strong focus here in this area to adapt the fuel cells, the stack, and all the other components toward heavy-duty applications. And one of the first way we can see this is with the very ambitious KPI in terms of the durability. 20,000 hours is a big leap forward compared to what we had in the previous calls in the past, in our past joint undertaking. All of these at the same time would have to be achieved without sacrificing the power output, which is also a key aspect for the heavy-duty applications. It is important to mention in this call that the focus is at stack level and not MEA level, because this is indeed the focus of the next call, which is focusing on MEA. The logic is very similar. Also here we will find the same set of targets, KPIs, which are of course adapted to the MEA. So in terms of durability, we still have the mark of 20,000 hours that will need to be achieved, and also in this case without sacrificing the performance. Being this not at stack level, of course, we are also paying attention to the cost, and especially to the PGM loading, that, as we know, traditionally is one of the elements that is best fit to help us to reduce the cost of these components. Durable catalyst, chemically and mechanically strong PEM, as well as electrodes adapted for heavy-duty applications, will be the focus of the call in this case. The MEA validation will have to be done through a single cell or short stack using the EU-harmonized protocols at the end of the call. So these are the first 2 calls, research and innovation. We then meet our first flagship projects in the transport application. And as I mentioned earlier, here the purpose of this call is to deploy and operate in real-life conditions 150 trucks. The scope of this project is also to address as many use cases as possible, meaning going from the regional distribution all the way to the long-haul transport. And therefore, the fleet will have to be divided both rigid and tractor. So both configurations are within the scope. At least half of those trucks will need to have an autonomy of at least 600 kilometers, and the majority of the fleet, overall fleet, will also have to address the long-haul applications. In terms of the use of those trucks, they will all have to be operated, each one of them, for a minimum of 2 years, and according to how they are being used, what is the use case that we are exploring, they will have to achieve 40,000 or 60,000 kilometers each year. However, we are not operating trucks, of course, for the sake of it, but it's because we need to gather important data about how they are performing. This will inform us also for the future calls, how to shape them, how the fuel cells and hydrogen systems are performing in heavy duty. Therefore, that's why we insist a lot on the submission of the inclusion in the proposal of a solid data monitoring strategy. This is a really important aspect. And then we come to the last aspect I would like to highlight here for this flagship project, which is the cooperation with the CEF for Transport program that I mentioned earlier. The funding for the HRS will not come through our call, but will have to be sought somewhere else. And we are in particularly referring to this program, which is very suitable, as we heard this morning. We continue still with the road applications, and we go back to what we define as the building blocks, the development of components, and we focus here on storage. Obviously, the capacity of storing large amounts of energy on trucks is one of the enabling conditions. However, and in that sense, the liquid hydrogen storage option is particularly interesting, but we still have quite a lot of doubts which are surrounding the potential losses of hydrogen due to boil-off, what is the interface for refueling, and what is the actual capacity that can be achieved. Therefore, through this call, we are launching a full-scale analysis of existing concept of liquid hydrogen storage on board, which should lead then to an analysis, which in turn will lead to a strategies on how to improve some key aspects of these solutions, such as the tank composition, volumetric efficiency, and potential, and how to address potential losses of hydrogen. Within the framework of this program, a full-scale liquid hydrogen tank system will have to be produced and then tested in order to validate whatever has been proposed. And this concludes the first 4 topics, which are dedicated to road transport application. And we now, apologies, that's some problem with the slide here. Apparently, I pushed the wrong button. Yes, there we go. So we are now moving to the second flagship project, and we are moving to maritime applications. As I mentioned earlier, the scope of this call is to deploy 5 inland waterway vessels with fuel cell and electric propulsion. These 5 vessels can be either the result of retrofitting or brand new designs of vessels. But what is important here to note is that all of those, in both cases, it's important to address those topics which are responsible for the largest amount of emissions. In terms of power, all the fuel cell solutions will have to be of at least 500 kilowatt, and they should be modular and easy to scale, as in fact the preferred power output should be of at least 1 megawatt. 2 bunker solutions should be available in ports, and it is also suggested that to convert a barge into mobile bunkering solutions for refueling operations. Also in this case, as in the previous flagship projects, it will be important to present a solid data gathering strategy and also to establish a strong cooperation with the CEF for Transport program for the financing of the HRS deployment. We move on now to the last 3 calls, which are dedicated to transport and in particular to aviation. Similarly to the logic that we have seen also for the heavy duty, where we had first a call dedicated to stack and one to MEA. Also in this case, we have first of all a call that is dedicated to the development of stacks for aviation purposes. And this means that a particular set of requirements will have to be met. First of all, in terms of power, the minimum power will have to be of 250 kilowatt, but also in this case, it will have to be able to be scaled up to 1.5 megawatt. In addition to power, there are also other specific aviation requirements that will have to be taken into consideration, such as the temperature, pressure, vibration, durability, and safety. All the solution activities will have to be validated at the end of the project via lab and ground test to prove the feasibility of the concept that have been put forward. We then move on again. Also in this case, we are looking to the liquid hydrogen storage solutions, which is quite important as well for the aviation application. And in this call, there are 2 demonstrators that will have to be set up. The first one is focusing on the tank itself, that will have to address the requirements of light-duty vessels. Therefore, a lot of the focus is really on the selection of materials that will have to primarily grant lightweight solutions. The second demonstrator instead focuses a lot on the integration of the operation, the validation of the operation of this tank within the vessels. So it's the development of the overall system plus the development of the balance of plant components. Throughout the call, you will see that there are also some additional very specific requirements that needs to be addressed, which are specific to aviation. For example, the sloshing effect, so that refers to the liquid movement of the liquid hydrogen within the tanks. This will have to be carefully modeled and understood. And there is also an overall strong focus on the safe operations. We then move on to the last call, which is dedicated to the development of aviation-specific disruptive fuel cells. So similar to what we have seen for the stack code, there is the similar logic with a number of KPIs in terms of durability, performance, and mechanical strength that will have to be achieved. But on top of that, there is an accent here in this call on the temperatures. So the solutions suggested, the fuel cells developed, they will have to be able to operate at a minimum of 120 degrees and more in constant operations. And finally, one aspect that is still highlighted in this call, it is not only about the development of the best-in-class components such as the GDL or the catalyst or the ionomers. It is also about seeing how all these different components are interacting among them, how the interfaces are operating. Therefore, why there is also a strong focus on assessing the overall architecture of the MEA. And with this, I have concluded this overview of the 8 topics which are dedicated to transport in this call. Thank you very much for the attention. Mirella, back to you.
Thank you very much, Pietro. Thank you very much again for guiding us through the next 8 topics dedicated to the end use of hydrogen into transport applications. And again, please stay with us here for getting questions. I can again encourage everybody to submit questions. We got a lot, I have to say. But please do so, because I think this is the role of today effort, that we guide everybody, all applicants, interested applicants, through this, through our call. And we are here to clarify any questions you may have. So please, if you feel like dropping a question, do not hesitate. Okay, moving on. We continue on the end-use applications of hydrogen, and I would like now to give the floor to Antonio Aguilo. He's another project officer from my team, dealing with the end-use applications of hydrogen for heat and power. So, Antonio, the floor is yours.
Thank you. Thank you very much, Mirella. And indeed, I'm going to give you an overview of what do we have this year in terms of clean heat and power. Just to point out, first of all, that we are looking at the multi-financial framework, and what we want to do throughout these years is really to support European actors, European supply chain actors, to develop solutions that are able to use hydrogen to provide clean, renewable, and flexible heat and power. And we are going to do that through a number of calls. This year, this is going to be the focus. It's about cost reduction through manufacturing, in particular for fuel cells. We also want to start the partnership, if you want, by supporting a number of topics that will allow fuel and technology diversification. And also, it's about supporting technologies that are able to provide, to enhance system flexibility. One of the main novelties, I mean, in the former joint undertaking, the support that we were having was really fuel cells. I mean, we were supporting for a number of years fuel cell development, demonstration projects. This year, we are increasing the portfolio of solutions, I mean, throughout the Clean Hydrogen Partnership, and we are extending also our support to include gas turbines that are able to run on different admixtures of hydrogen in the gas. So that's one of the main novelties. And then also, when it comes to the topics that I will describe later on manufacturing, we are actually, as in the past, we were having mainly in the projects the fuel cell manufacturers, component manufacturers. Here, what we want to do this year is to bring the equipment manufacturers actually at the core of the action, so that the benefits are actually, if you want, pass through the whole of the fuel cell supply chain and not limited to a few companies only. We have 4 topics this year. The first one is the innovation action looking at manufacturing, and that's going to have a deadline of September 22. Then, with an immediate deadline in May 22, we are going to have 3 topics looking at research and innovation actions. And in each of these topics, we will be able to support 1 project. However, for the last one, which you can see here, dedicated to gas turbines using hydrogen admixtures, we will be able to support up to 2 projects in this year. So, the first topic, it's about the design and the industrial deployment of innovative manufacturing processes, as I've mentioned before, and there is the focus for solid oxide fuel cell system and components. It's about looking at what are the most manual manufacturing steps and to automate them. And it's also about time and resource efficient quality control, all of this aiming to reduce the costs of the most expensive components for solid oxide fuel cells, which is the stack. We hope that through this topic, we will show how we can get to capex for the stack of less than 800 euros per kilowatt at large production volumes if we look at a single manufacturing line. Now, the progress of this topic is measured by increasing manufacturing readiness level. That's important. It's a purely manufacturing topic. And it's about adapting and developing manufacturing processes on a prototype tool. As I mentioned before, the equipment manufacturers have to be at the core. The idea here is that this topic can benefit all the solid oxide cell manufacturers industry. And there is no prescriptive way in which manufacturing processes can be targeted. There are several of them that can be addressed. And it will be important as well that proposals foresee synergies with another European partnership dedicated to manufacturing, which is the Made in Europe partnership. The next topic, it's about fuel diversification, as I've mentioned before. It's a research and innovation action, and it's about designing, manufacturing, and validating an ammonia-driven fuel cell system. The topic is looking at systems between 5 and 15 kilowatt. You can see that the most immediate outcome, if you want, is to looking at a small-scale autonomous application like remote infrastructure, like telecom towers. But it's also important to have in mind that the topic is about setting the basis for the development of larger systems, 100 kilowatts all the way to the megawatt, for applications where ammonia is already available as a commodity, could be harbor. So it's important to have that long-term perspective in mind, even if the topic itself is targeting 5 to 15 kilowatt system. There are a number of KPIs that have to be achieved: electrical efficiencies above 50%, low degradation rates, availability above 90%, and then we are really looking at least having 3,000 hours of validation. Work can take place at all the levels of the system, stack, fuel cell system level, also including the balance of plant, and of course the ammonia cracker. We are looking here at an integrated ammonia cracker. And to foster the exploitation of the results, it's important that the fuel cells manufacturers should be part of the consortia. CapEx target in mind, less than 5,000 euros per kilowatt at 100 megawatts of annual production. Third topic, it's looking at designing, developing, and validating a reversible solid oxide system. Here again, it's a research and innovation action. We are looking at a small system of 5 kilowatts in fuel cell mode, at 15 kilowatts in electrolysis mode. But again, we are having in mind larger system, megawatt scale systems that could be, for instance, conceived in operation like nowadays we have wind parks or PV parks. We have to conceive also how these systems at larger scale could also operate in larger volumes and in larger capacities as well. System itself has to be able to operate with 0 to 100 hydrogen content in the natural gas. Very important to show the scalability of the systems for the reasons I have mentioned. We are really looking at megawatt scale eventually. And it has to have electrical load following capabilities. System is meant to be connected to the gas and the electricity grids. So it's important that it's able to take the gas from the grid in fuel cell mode, generating heat and power, but it's also important that it's able to inject the hydrogen into the gas grid when operating in electrolyzer mode. We are targeting system round-trip efficiencies of at least 38%. Stack degradation rates of less than 0.4% per 1,000 hours, and we need to have projects that are able to operate the systems continuously for more than 3 months. One of the important elements, of course, is to keep the CapEx to competitive levels, so it's important that the systems develop, use common balance of plant for all operating months. Objective is 6,000 euros per kilowatt or less in the short term, with views to having system of less than 3,500 euros per kilowatt in 2030. Last topic, moving now, until now we have been looking at the fuel cells. This one is really about retrofitting, if you want, or preparing the plant of gas turbines so that they are able to operate with 0 to 100 volume of hydrogen in the natural gas. The challenge here is to keep the performances levels and to keep the NOx emission levels of those of gas turbines operating on natural gas. The set of KPIs is well defined in the topic, so I suggest that you have a detailed look at that. And it's about, yes, there will be a number of experimental investigations. However, end of the day, the project has to be able to design and to demonstrate a scaled and full-size combustion system showing that it's able to operate in those conditions. And it has to be done in a relevant environment. Again, to foster exploitation of the results, we expect to have the gas turbine manufacturers as part of the consortia, and it's important that proposals can show how the required infrastructure can be accessible throughout the project proposed. We will be able to support up to 2 projects with complementary approaches. One of them possibly could be a medium and a large scale size turbine supporting those 2 projects just mentioned. And this is it on clean heat and power. So back to you, Mirela. Thank you for your attention to everyone.
Thank you very much, Antonio. Thank you for guiding us also through these technical topics and use of hydrogen for heat and power. And again, let's see if we get further questions. I think to me, at least, everything was very clear, and thank you again for that. Now we get into the last presentation of this part of the day, where we will look at cross-cutting, horizontal activities, also such as valleys or the strategic research challenge I mentioned in the morning. And with that, I would like to give the floor to another project officer, Alberto Garcia Hombrados, project officer in charge of all this challenging, I will have to say, mix and complex everything that we have to deal in cross-cutting. Alberto, the floor is yours.
Thank you very much, Mirela. Hello. Yes, as Mirela said, I'm going to present the topics of all these 3 horizontal areas, which complements, let's say, the activities that we have been hearing before. I will start with cross-cutting issues, and here the focus this year is to raise public awareness and trust towards these technologies, but not only to raise awareness, but also to provide guidance to others on how successfully or effectively raise awareness and trust in the public and key stakeholders in Europe. Also, we will be addressing safety-related aspects, on one hand, on cryogenic or liquid hydrogen transfers for mobile applications, in particular in new distribution applications, but also we will be touching upon the hydrogen injection management at the network-wide level, in which we are going to address all the aspects related with the management of the multi-gas network. We will be focusing on test methods and requirements for measuring devices. In particularly, we would like to develop the test methods, but also limits, to define the limits and the tolerances of the devices currently used in the gas network. And we have also one topic, and as we will see in a minute, concerning the support for the support of the cooperation with the African continent in order to shape this future cooperation with different countries in Africa on renewable hydrogen technologies. So let's have a look at the different topics. We have in cross-cutting issues 5 topics from different actions, type of actions, coordination and support actions, but also research and innovation actions. The budget ranges from 1 to 3 million, and you can see as well that 3 topics. The deadline for 3 topics is end of May, while the deadline for the other 2 it's almost the end of September. So let's have a look at the different topics. The first topic is, as I mentioned, to raise public awareness and trust towards these technologies and all the benefits that these technologies can bring into our society. So what we are planning, where we would like to focus is on building on the learnings from past and ongoing successful initiatives or projects, raising public awareness to further understand how the people perceives, the attitudes, the perceptions, and so on, so that based on that learnings, the proposals or the projects can develop guidelines or good practices and materials for raising awareness and trust for others. Also, within the topic scope, the projects will have to set up engagement activities in order to test and further develop the guidelines and the good practice and the materials that will be one of the outcomes of the project. The focus should be on the technology in general, and the target, it's the general public or the public, but also stakeholders from key sector or territories from which, let's say, the technologies can really play an important role. The activities should have a comprehensive coverage with special attention on the EU 13 countries, And also that's something that I would like to highlight is that the proposals of the project should bring or should propose metrics and indicators to quantify the impact of the activities and the engagement activities, among others. The second topic, it's about the safety on the liquid hydrogen or cryogenic transfers in new distribution applications. Proposals are expected to address at least 3 applications on hydrogen mobility, like, for example, we mentioned ships, trucks, or stationary tanks fillings. We expect that the proposed projects provide practical and science-based outputs concerning risk analysis, safety barriers, safety distances, loading procedures, operative conditions, so that based on all these outputs, they can provide recommendations, guidelines, and procedure to, on one hand, the industry concerned, but also authorities and the standardizations committee, so that altogether they can provide guidance to the industry and stakeholders, but also very important to support the development of standards. The third topic is about the development of technical documentation for safe multigas network management. So we expect the projects will develop methods, tools, technologies, guidelines for the management of the network, but also for the tracking of the gas quality. And we expect to cover both the transmission or higher level pressure distribution, the transmission network, and the distribution network. Projects are expected to address the injection of hydrogen. In particularly, we mentioned that on one hand, they should develop modeling tools for the simulation of the network, but on the other hand, also they should identify key technologies for quality tracking and also for mitigation of the variations of the concentration of hydrogen. Besides, the projects are encouraged to analyze also the gas equality impacts on both repurposed and new pipelines, and in addition, tackle upon the inspection of components' behavior, so that they are expected to build a database of the different components and also to develop protocols for these purposes. Altogether, we believe that the project will be able to provide guidance and support the development of European standards in this particular matter. The fourth topic is the development of test methods and requirements for measuring devices in the gas network, as well covering transmission and distribution networks. We expect that the projects will develop and validate test methods, evaluate impacts on the devices, etc., but also, more importantly, to define the limits and the tolerances of the devices currently used in the gas network. The range of the test methods should cover from 0 to 100% of volume of hydrogen, and also we have somehow listed some of the measuring devices that should be covered, like flow meters, pressure transmitters, quality analyzers, so on and so forth. Also, something very important is that the projects should provide recommendations to both European and national gases and metrology associations, and also standardizations committees, so that with this type of project, with this project in particular, we will have guidance for others on how to test the different measuring devices, but also we will support the development of European standards particularly on the test methods of measuring devices. And last but not least, the last topic on cross-cutting issues is related with the cooperation with the African continent, and in particular on renewable hydrogen technologies. In that sense, we do expect that the proposals or the projects will perform a multidisciplinary research to identify the measures, the enabling conditions, and all the issues needed to develop both renewable hydrogen technologies and a market in the African continent. In that sense, we expect that projects will address potential research and innovation and technological options for the production, storage, transportation, distribution, and usage of renewable hydrogen, with a strong emphasis on the environmental impacts, business models, techno-economical aspects, industrial implications, market opportunity, as it is described in the topic. Also, we do expect that the projects will identify potential geographical and thematic areas for the cooperation between the European Union and the African countries, and at least should develop 2 areas in detail as an example for the others geographical and thematic areas identified. One of the outcomes very important of this project is the development of what we call SIR, the Strategic Innovation Roadmap, highlighting the mutual benefits for both the African Union and the European Union in this cooperation. And something that is also included in the topic description is that the project should propose the creation of a network of major African actors in area of renewable hydrogen production, but also in transport and in use. That's all for cross-cutting issues, and I'm going to present now the two topics on hydrogen valleys and the last topic on strategic research challenges. So we have two topics on hydrogen valleys, one at large scale, one at small scale, with 25 million of funding, the first one, 8 million the funding, and the deadline on September. Both valleys are Innovation Action's flagship projects, while the topic on the research, strategic research challenge, presents a budget, an indicative budget of funding of 10 million with the deadline end of May, being a research and innovation action. The first area is hydrogen valleys, and here the focus is to develop and deploy and demonstrate both large and small-scale hydrogen valleys that can grow in time and be sustained, and also can be replicated elsewhere. We plan to cover the focus of the hydrogen valleys, as you may have heard this morning, is to cover the complete value chain of hydrogen, but also, very important, to contribute to the European competitiveness by supporting the European value chain. Valleys, almost per definition, they should show that hydrogen is an enabler for sector coupling and also for supporting the additional integration of renewable energy. The novelty in the large-scale hydrogen valley is that it is not limited to the boundaries of the valley. It presents interlinkages, beyond the valley boundaries as mean to contribute towards the hydrogen infrastructure backbone at the European level. While in the smaller scale, we would like to stimulate hydrogen valleys in areas with no or limited presence of hydrogen up to now. So that's the novelty. If we have a look at the different topics, as I mentioned, the first topic is on hydrogen valleys at large scale. So we would like to deploy and demonstrate a large-scale hydrogen valley with interlinkages outside, let's say, the territory or the boundaries. The production of hydrogen, renewable hydrogen, has to be higher, or at least 5,000 tons per year, using new hydrogen production capabilities and supported by a guarantees of origin scheme, either on the national level, and if it's not available, supported by the certified guarantees of origin scheme. At least projects should cover include two FCH end users applications from at least two different sectors. The sectors are well defined in the topic descriptions and cover energy, industry and transport applications. Should demonstrate as well existing on new hydrogen markets, the contribution to economic growth, the impact and replicability, commitment of stakeholders is also very important through the letters of intents. Something that is quite relevant for this type of initiative and the valleys is the financing structure. And in that sense, we do expect that the projects and the proposals present a financial structure and strategy describing the business model, but also envisaging the different sources for the co-financing, co-funding that might be required for the valley development. The second valley is about the small scale, and in that sense, the topic is quite similar, but here the focus is on areas of Europe with no or limited presence of hydrogen valleys up to now. The production rate, because it's a small scale, it's limited, or it should be at least 500 tons of renewable hydrogen per year, supported by a guarantees of origin scheme. They should supply, instead of two sectors, just one or more sectors or applications from the different sectors that we mentioned, mobility, industry, energy, and at least 20% of the hydrogen produced for each of the two main applications should be at least 20%, sorry. The value should demonstrate, as in the previous case, existing and new hydrogen markets, contribution to economic growth, the impact and replicability of the valley itself, and also should demonstrate the commitment of all the stakeholders, public, regional, national, and even private, of course. As similar as in the previous case, the financial structure and the strategy describing the business model, how the co-financing and co-funding is going to be integrated for the success of the project should be very important. It's very important and should be well developed at the proposal and the project level. And last but not least, I will just take one more minute to present the topic. We have only one this year on the strategic research challenges. In that sense, the topic is addressing the sustainability and circularity of the materials, components, subcomponents of electrolyzers and fuel cells. The idea, yes, thank you. Just a second. The focus is removing the critical raw materials and materials with, let's say, environmental concerns from these technologies, electrolyzers and fuel cells. And the focus should be on the development of low or free critical raw materials catalyst and poly or perfluoroalkali free ionomers according to the SRIA's KPIs. In that sense, please go through the topic because all the KPIs are very well detailed for the different technologies covered within this topic. We would like to improve the content of, we would like to improve, let's say, the recovery of critical raw materials and ionomer from the scraps, weights, and end-of-life equipment as well. The project should at least propose 3 innovative solutions for each of the technologies covered. You have there the list. And we do expect the breakthroughs in electrocatalysis, coatings, electrode architectures, but also in cell designs. And all these improvements, let's say, should be supported by a life cycle analysis in order to demonstrate the benefits for the environment or the environmental benefits of the solutions proposed. And with this, I think I've reached the last slide. So thank you very much for your attention. And Minela, back to you.
Thank you very much, Alberto. Thank you for presenting the last set of topics. And with that, I think we guide you through the 41 topics. As I said, we received a lot of questions, and I thank you very much already for that. From just reading the questions, of course, we will not have time to deal with all of them or to answer to all of them. And feel free also to use the contacts on our website, the info generic mailbox, whenever you have a question on our call, even later. What I want to say briefly here is please read the text of the call topic. Do not pick up on the 3 words that we put right now on the slide and make up the mind about the call or about the topic, because just by reading the questions, I see a lot of unclarities on your side. So please read the text. Believe me, it's not our desire to write hundreds of pages of call topics. Any word in the call has a meaning. So please read the topic and please read the text. And only after reading the full text of the topic you do not understanding, drop us a question. Because I believe, again, that a lot of your questions are coming just by, how can I say, superficially reading the text of the topic. Huh? So I would kindly recommend to read first and then put the question. However, let me try to address some of the questions. I have all the speakers around me. We'll see how we can manage all of them. I will start myself with some general questions. So first, we received almost from the morning a question on the list of the members of Hydrogen Europe Research. We will get a presentation later, so this afternoon. If you could still stay with us, you will find more information about our private members, Hydrogen Europe Research, how can you join them, which are the members, where you can find the list, etc. Briefly, just to comment on that, through our website, through our links to our members, you can find, of course, the website of the private members, and you can find the list of the members there. But again, if you could stay with us, please stay with us in the afternoon and you will find out more. Second question I would like to take myself, it's about a brokerage event. Yes, we would have loved to have such an opportunity, but as you can see, it's extremely challenging even to do a hybrid event like we are trying right now. At least that ourselves here, we sit together. I have to say, after 2 years of pandemics, it's extremely difficult now to do a brokerage event and pure networking like, yeah, in an ideal world should have been. So we just hope that by next year, with the next call, we will be able to do that. But the answer now is no. We will not have the possibility for a brokerage event. What I could only comment now is that we will, for example, have different national info days in different countries, and there are several planned, for example, in France, in Portugal, in Spain, in Slovenia, coming up this month and next month. So we try to repeat again the information there. Then I would like to go through another general question I would like to take. It's about UK applicants. We have received this question. We were expecting to receive this question. I have to say, for now, UK is not yet an associated country to Horizon Europe. We know that it has entered into discussions to join as an associated country the Horizon Europe. For now, the participation is open, as for any country around the world, unless the country is sanctioned, as we well know about Russia and Belarus. But UK could participate in our call, could require funding in our call, pending signature of an association agreement. So what we will do, we will evaluate the proposals with UK applicants like they were part of Horizon Europe, and we will draw the attention to the consortium in two-steps approach after the evaluation in the information letter if they are successful, and before the signature of the grant agreement, that funding needs to be secured from other sources in case UK has not joined or as an associated country Horizon Europe. I hope my answer is clear. Do not hesitate again to come back to us. This is the rule in general for Horizon Europe. It's not the rule for our joint undertaking as regards UK applicants. So we follow mutatis mutandis these rules of Horizon Europe. Now, I would like to take few questions for the project officers. And Nikos, if you could get into to help me here, I would like if you would like to comment on the on one of the questions asking, for example, why we have not. For example, publish anything in this call 2022 on anionic exchange membranes electrolysis. Would you like to give a try on this one, or I would compliment you anyway?
Yes. Actually, we foresee this. Topic 1.3 is about game changer low temperature electrolyzers. And there, anion exchange membrane electrolyzers are mentioned, and there is a rather challenging target of developing a 25 kilowatt stack. So I would advise the lady or the gentleman to look again at this topic.
Thank you very much, Nico. Like I said at the beginning, please read the topics carefully. And then drop a question to us if still not unclear. And another question for you, Nikos. It's on the topic 8. It says in the questions. I guess it's 1.8. And it's asking, can a project meet the hydrogen production target in the call text with a more efficient electrolyzer, and so to have a capacity lower than 25 megawatt?
Right, interesting question, but the call topic calls for at least 25 megawatt electrolyzer and at least the 1,500 tons over a year. Indeed, maybe you could reach the production target with a more efficient electrolyzer, but you still need to satisfy the at least 25 megawatt. And besides this, and on a larger picture, I would like to point out that our most recent large demonstration project of the electrolyzers, the Jewels project, was a 20 megawatt electrolyzer where our support was 11 million for a total budget of 42 million. So use this as kind of guidance as to the scale that we eventually expect to receive, the scale of the project. And it's a flagship project like Ms. Athanasiou mentioned. We expect that our funding will be lower than the ambition of the project. So please take those considerations in mind.
Thank you, Nikos. Thank you very much. Let's move on. There are many other questions on Nikos' presentation, but like I said, I decided to select them to try to cover all the questions that as much as possible, the questions that we received. And again, for the other ones, please do not hesitate, if you still have them after reading the text, please do not hesitate to send them to us in writing via email, our info generic mailbox on our website. Okay, let's take you, Alberto, next. We received several questions on the Africa call, on the Africa collaboration call. It's asking, first, why Africa? I think this is a bit very political question. Why Africa and why not Central America and why not Asia? If you could dare an answer to that, otherwise I will comment anyway.
I would just say, why not? Basically also because, as you know, in the hydrogen strategy, we have very challenging goals, 40 gigawatts of electrolysis, of hydrogen, renewable electrolysis in Europe, and 40 outside. Africa continent, it's close to Europe. There is a potential, a huge potential for deploying renewable hydrogen technologies and deploying as well a hydrogen market in the African continent. So we have considered that it was the timely moment to shape this cooperation and to start putting the pieces, let's say, in the puzzle, so that we can both strengthen our cooperation and become more resilient and more, let's say, renewable and clean, thanks to the hydrogen technologies.
Yeah, and I think the next related question to still on Africa, I guess we are having a listener or in the audience, probably companies from Africa that are interested in this.
Yes.
The question is for Africa call or topic, which are the minimum number of consortia partner, and if there is any ratio between European and African partners?
Yes, as such, the type of action is coordination and support action. So in that sense, the rules are clear. It could be just one entity submitting a proposal. In any case, if you see the different eligibility conditions in this topic, there is one of the requirements, and I'm reading the topic right now, is that at least 3 partners from 3 different African countries must be part of the consortium. So that's an eligibility continue. If this requirement is not compliant, the proposal is not eligible and therefore cannot be awarded with the funding. And then concerning the ratio between European and African, it's open. So it's up to the applicants to demonstrate which ratio they believe it's the most suitable, and in that sense convince the experts that their proposal is the best and should be awarded with the funding. That would be my answer.
Thank you, Alberto. I think I will now take some general questions still. Maybe Pietro joins us for next question. So I'm not sure if you could get into the picture. Yeah, thank you. Yeah, okay, we're getting better with a hybrid way of doing and closer. Luckily, COVID is not between us anymore. So thank you very much. Let's move to Pietro. I think we have received one question about the topic 3.2. And it's asking if the heat recovery component could be an eligible MEA, where is it? Could be an eligible MEA component under this call. So the heat recovery.
Frankly, for this specific of this call, maybe it's better if we will get back to you by email, if you can send it to us. So we will have to see some of the details that of the specific calls. As you imagine, there were many calls. I would like to give you like the proper information on this one.
Yeah. Thank you, Pietro. No worries. So if you could clarify your question in writing, so we can give you a better informed, if I can say, answer. Thank you, Pietro, for that. Indeed, the question is not extremely clear. For the Strategic Research Challenge, it's asking, although Industrial Advisory Board is encouraged, the industrial participation as a consortium partner is not clear. Could it be clarified? Who wants to take that question for the Strategic Research Challenge? Alberto?
Well, I can try to address. Yes, first of all, keep in mind that for this challenge, this is a strategic challenge, and as such, one member of either Hydrogen Europe or Hydrogen Euro Research should be part of the consortium in order to achieve those objectives. Concerning the involvement of the industries, I think the concept applies again. It's up to the applicants to convince the experts why 70% of industry should be involved, or just 20%, so that the information is clear in the proposal. Don't forget that every proposal will be assessed by independent experts, and in that sense, they will review your arguments, the grounds to propose that distribution or the involvement of the industry, and based on their expert judgment, we will select the final project for funding. So in that sense, it's open. It is not specified as such in the topic description, and therefore I would recommend you to include solid arguments to convince independent experts on this particular topic, who will assess if this is the best option in Europe for this cooperation with the African continent.
Okay, thank you, Alberto. Again, I see a lot of interest on this Africa topic.
Yes.
I see a lot from the questions we receive, and I see even people not happy with our answers. And they say that why not is not an answer. And I would like to comment on that because I agree that maybe this is a way not to get into a geopolitical discussion here. Why have we published a topic with Africa and not with other countries around the world? I think, and this I dare another answer that you may or may not be happy with, but I dare to say that just by reading the hydrogen strategy, also like Alberto mentioned, from a geopolitical point of view, I think is in the interest of Europe to get the most closer renewable resources available, and Africa is one of them, and that's the interest for Africa. And this is where our public member, European Commission, through their hydrogen strategy, is interested to see with this topic the feasibility of such of cooperation and opportunity. We are not now developing projects in Africa. We just want to do the first step, assess the feasibility, that we again build on the possibility that we have a lot of resources, renewable resources in Africa, close to the European continent, and we bring them and we transform them in renewable hydrogen to indeed be less dependent of other resources from other sources around the globe. I hope my answer is better than the why not.
If I may also complement, also keep in mind that the topics that are published in the call are lengthy discussed between the members of the joint undertaking. In that sense, Hydrogen Europe, Hydrogen Euro Research, and the European Commission has decided and agreed that that was the time. It was the time to start looking at this cooperation and see with the African continent. So it's not us from the program office deciding which region should be focused on this year. It's all together, collectively, it's been decided. I would like to make clear as well.
Yeah, it's a good clarification. I mean, yes, indeed, we are implementing the call, but indeed, the decision is our governing board, whether to members, European Commission and private members. Yes, thank you. That helps also to clarify why we do not feel comfortable, I would say, to get into such discussions. But again, I hope we have discussed a lot on this topic, and I would like to recommend to stop here. Then let's move on. I see a general question about releasing answers to the FAQs. No, unless the question is a frequently asked question, we will not release answers to every single question that we are getting. If we will receive, and there is a criteria on what does it mean for a question to be a frequently asked question, unless we receive it frequently, we will not publish it. So I hope that also answers that question. So let me look again through the questions here, and to try to select them. I can tell you we are flooded of questions lately. Let me take one of the valleys, and I will like to ask you, Antonio, to comment on that, to also give you the opportunity. Although presented by you, Alberto, Antonio is the one following the valleys. So on the valleys, the first question we got was if there is any minimum threshold for synergetic or additional contribution. And how broad the consortium should be. So there are two sub-questions, if you want.
Yeah. I mean, thank you for the question. If I understood well the first part in terms of how synergetic, I mean, this is a consequence of the scope of the topic. If we talk about the largest scale valley, it's at least 5,000 tons of hydrogen produced. Of course, there is a number of requirements in terms of what type of end uses we need to get there. And we can only support that project with 25 million euros, meaning that if you put all that together, certainly to reach the expected impact, there will be significant levels of co-funding that will be needed. So there is not such a requirement, but I think we can foresee, and this is why the emphasis has been put on securing co-funding, whether it's through national programs, whether it's also through regional funding. It's there because it will be necessary. So again, the focus should be on the impact, see where proposals end up in terms of co-funding that is necessary, and then that would come up with a credible proposal. That's what I would say. In terms of how large the consortium should be, again, this is a valley. We understand, of course, that this has a very strong regional nature, if you want, or geographical confined nature, because in this one, in the larger scale, we are talking about having or encouraging applicants to have interlinkages across different regions. But you need to have all the actors that are necessary to make your proposal credible. And that can be anything from end users that could be the ones that will take over the hydrogen produced, but it could be also about developers of hydrogen production projects and hydrogen production plants. We need also the public authorities, private sector. There is an element on the topic test in relation to that, which is that we should have that element of how the stakeholder engagement is already at proposal stage. I believe the topic, please have a look, but I believe it calls for at least having some letters of interest, and letters of interest that should be somehow reflecting the specificities of the project, not general letters, but actually what could be the support of the actors submitting such a letter, in such proposal. So again, to end up, look at the impact, see how much co-funding, co-financing you would need that would make the scale of the project, and then see who do you need to make it credible. And that would end up saying and putting down a credible proposal that experts will eventually evaluate. Hope that clarified the 2 points.
Thank you, Antonio. And I have to say many questions we receive on the valleys. They're clear that they're popular topics, and I think especially for the end users, for the regions, maybe for the local governments, for the municipalities, probably it's an interesting way to get some support from us for a first of a kind demonstrator in some regions, especially for the small one, which is for places where never maybe a hydrogen project was taking place. So I guess this is why so popular. But like I said also, and I'm repeating myself here, please do not hesitate to contact us through our info, again, mailbox on our website under the contacts. There is an info mailbox, generic mailbox, where you can drop any question during the call when the call is open, and do not hesitate to drop us there any question or a follow-up question, and we will get back to you. I can guarantee that with a detailed written answer. And just to clarify, because I saw 2 or 3 times, Antonio, also on the valleys, sorry to come with a third follow-up question. There were questions about if there is a need for 5 valleys or is the need of a valley with different followers. So I think you can also comment on that.
Okay. Yeah, I mean, have in mind that the topics are similar but are not the same. So it's important that you look at them individually in this regards, no? If we look at the smaller scale, the answer would be, well, we are looking at the valley. I mean, the characteristics have been briefly mentioned by Alberto. So we are looking at least 500 tons of hydrogen production with 2 end users or 2 applications, and that could be a valley that goes all the way from production to distribution, storage as necessary, and end uses, and that could be confined in a region. And similarly to the large-scale valley, but there things are a little bit more, if you want to elaborate it, because we want to encourage applicants to create interlinkages beyond the valley boundaries, meaning that we could have different configurations in such a topic. And the idea here is that we can start exploring and developing hydrogen markets that go beyond a very confined geography. So we could have different configurations there. There are some requirements in terms of all the different things that the valley should have, but we don't need necessarily have a lot of valleys in there. If the question comes, I mean, a lot of different regions per se, but we need to have those interlinkages that could be cross-regional, but could be also cross-member state. It really will depend on the proposal. But if you ask the question because of what we say in terms of replicability, that's a different thing, because what we want to do is that whatever intervention you propose in your valley, then, of course, we need to have, and it's very clearly written in the topic, an element of replicability. We want to foster the replication of valleys elsewhere. And for that, it's important that the proposals have a right set of activities for that, a right set of actors involved. Whether they have to be partners or not is up to the proposers, but we want to make sure that through the valleys that we are supporting, we can have additional valleys stimulated as well, and we expect targeted activities on these regards. It's not simply by doing a document that we put on the internet. No, we want to really have credible replicability in those projects. So that's very important, and this has been the case since we're starting to support the valleys some years ago now.
Yeah, thank you again, Antonio. And there are, like I said, many other questions regarding the funding rate and many others. Again, if you have not received an answer today, and after reading the text again, you do not find an answer, please drop us a question in writing to our info generic mailbox. We will get back to you as soon as possible. Moving on to you, Pietro, for another question. There is a question on the topics on the aviation. And it's asking what is the project duration and what is the link, or if there is any link with the activities in the clean aviation joint undertaking with our colleagues.
Yes, thanks, Mira. Well, for the duration, no, we haven't indicated a specific duration in the call. That means that it's up to the consortium to provide also a credible timeline for the implementation of the action, and this will then be assessed by the evaluators. So, not too ambitious, not too long, you will have to find what is the right balance if we didn't put an indication. And when it comes to the specific cooperation with the clean aviation joint undertaking, again, this is clearly specified in each one of the calls. It is specified, for example, that certain components will be developed until a certain point, is the logic of the building blocks, and then this development, the integration to the aircraft, will be further developed through calls that are put forth by the Clean Aviation Partnership. I believe that in each one of the calls, this is clearly specified where our activities ends and where those of the other joint undertaking are beginning.
Thank you, Pietro. I mean, the clear collaboration with the other partnership, with the Clean Aviation Joint Undertaking, is reflected in our 3A, the document that I presented in the morning. So if you will look there, you will see exactly what do we do, what the Clean Aviation Joint Undertaking we do. And for the topics of this year, like Pietro already mentioned, we are providing the building blocks for our colleagues in the Clean Aviation to take them, integrate them, demonstrate them in the new hydrogen plane. So that's briefly, and thank you, Pietro, again, what the intention is there. Alberto, getting back to you. Yes, again. We got few questions on the purity, gas purity. Huh? I'm not sure I understand them very well, but let's give it a try.
Let's see.
So it's saying for the call, I guess this topic, dealing with measuring devices.
Yes.
How important is measuring gas purity for this call?
I would say as important as relevant. Currently, there is a standard for testing this kind of measuring devices. And what we are trying to confirm or address is that there might be a need for developing new standards or new testing protocols, taking into account the blending of hydrogen and natural gas. So I'm not an expert in measuring devices personally, but I would, yes, reply that it's up to you and as relevant as needed. If it affects the measurement principle or if it affects the accuracy, I guess that you are in a better position to judge if the purities are essential aspects that needs to be also addressed within the test methods that it's one of the outcome of the project. So.
Thank you. Thank you very much, Alberto. I think we only have time for one or two more questions. I think we are getting to the lunch break. So what I would like to pick up again from the many questions we got. By the way, I'm seeing some of them which you may have an answer if you stay with us for the afternoon. There are many presentations in the afternoon that will refer to the duration of a call, who should be leading a consortium, the composition, the eligibility criteria, the rules for submission and evaluation, the templates, etc. So if you could stay with us for the afternoon, you may find answers to your questions, and I do not want to anticipate with answers the presentations of the afternoon. So please stay with us. If you still do not find your answers, please insist and drop them again in the afternoon if that's the case. So I will not address those questions. The only question I still want to address, which came from the morning, was a bit, and it's a right question to ask. I was expecting it. It's a curiosity, I think, or a clarification on what is exactly the process of coordination between us, our call, and the CEF Connecting Europe Facility call. So it's a very good question, I have to say. And like Richard, our counterpart in the agency of the European Commission managing the CEF Connecting Europe Facility calls, like he said already, we have done the first step. The first step is to coordinate the calls. Our two deadlines in May and in September coordinate very well with the deadlines of the CEF in June and November. So the way we are expecting right now is that a consortium that wants to apply to our topic for vehicles, for trucks, or for vessels would have a complementary proposal to apply for the infrastructure for the hydrogen refueling stations along the TEN-T corridors to CEF. So there should be two applications. That's what we expecting now. Those that apply to us for vehicles will apply to the other deadline of the CEF for the infrastructure. Then internally, between us and Richard and his team in the European Commission, in the agency, again, overseeing the other program, we will coordinate that the two proposals will be successful altogether before signing any grants. It doesn't mean we will get into altering the competition or we will do something behind. No. We will just make sure that before we sign and Richard and his team signs, the two are complementary. That's the only thing we will try to make sure. And for that, that's why we openly, transparently ask everybody that is interested to do that to contact us for further guidance. We will be able to sit down with you, to have a meeting, to explain to you how to do it, to make it successful, if it's not already clear in the topic. Again, we hope we made it clear enough, confirmed by Richard this morning, but if you will need more guidance, please do not hesitate to contact us. We will sit together, we will explain how to make successful the two complementary applications if needed. I hope I clarified that. Yes, I recognize it's challenging for all of us, but I hope we can make it like Richard also showed this morning. We have a precedent or a precedence with the project Jive for buses and Merlin for infrastructure, supported by CEF. It works. We've done it. Why not to make it again successful for trucks and for vessels? So I hope with that I clarified this pending question from the morning. For the rest, again, bear with us this afternoon and do not hesitate to send, if necessary, follow-up questions through our info mailbox. Let's have a break now for lunch, for all of us, for you, for us, and we will get back at 1:30. So in about 1 hour, 10 minutes, that should give us sufficient time to refresh a bit. So I hope to see you all back 1:30. Thank you.